Okay, Algebra 1 students, here is a little video to help you with some of the concepts surrounding absolute value, beginning with what absolute value is. Okay? Here you can see I've got a little number line. It goes to 4 on this side, and it goes to -4 on the other side. Well, if I started at 4 and I wanted to get to 0, I could get there with 1, 2, 3, 4 steps, right? 4 jumps. Likewise, if I was at -4 and I wanted to get to 0, I could go 1, 2, 3, 4, and I'm back at 0. So you can see that absolute value is first and foremost a distance. It is literally the distance from 0. Okay? And that is why you can get to 0 from both the negative side and the positive side. And it also happens that one way that we can express absolute value as a function is as a piecewise function, which we've been learning about, right? We've been learning about piecewise functions. Let me move this out of the way so we can more clearly see that here's our y, our f of x, okay? Here's our equal sign. Here's our brace that marks that we're going to start with our 2 different function rules, or however many there are. So absolute value functions are negative x when x is strictly less than 0, and they're just x if x is greater than or equal to 0. Okay? So the point of this is that when you input a negative number for x, it's still going to come out to be positive. When you input a positive number in for x, it's going to stay positive. Okay? So that's another thing about absolute value, is that it is always positive. So when we were in class, those of you who are watching this because you were not in class, I had the students take this table of values and plot a graph. And this is what an absolute value graph looks like. And I also want to explain a couple of important things that absolute value graphs have that we're going to learn about with quadratic graphs next semester. But it pays to be introduced now. One of them is a vertex. Okay? This side of the graph is y equals x, right? When x is equal to or greater than 0. This side of the graph is y equals -x when x is strictly less than 0. Okay? This point right here at the point is called a vertex. It is a turning point in a graph. Okay? It is a place where the graph changes from one direction to another. Here we have a decreasing function. It changes to an increasing function. Where that happens is a vertex. Okay? Then another thing that absolute value graphs have is they have an axis of symmetry. Okay? An axis of symmetry is an imaginary line that goes right through the vertex of a graph. And it divides a graph into two halves. In the case of this type of graph, it's two precisely mirror image halves. If you folded this graph over, you would see that it would be the same graph. And likewise, if you folded this on the other side, it would be the same graph. Okay, one other thing that I want to introduce you to at this time is the formula for the transformations of an absolute value function. Now you might remember that I showed you guys this formula in the context of point slope form of a line. And I told you at the time that this formula is the same for every single function family. They all have slopes, they all have either vertices or points on the line, on the graph, and that is what A represents the slope, H and K represent the vertex, okay? Now, here is notes to your future forgetful selves. I'd like you to please write this down, take note of this, take a picture of it, screenshot. Here are the things that I want you to remember in the upper left-hand corner about absolute value. Okay? That it is a distance from zero, that it is always positive, that it is a piecewise function of this structure, that y equals negative x when x is less than 0, and y equals x when x is greater than or equal to 0. Absolute value graphs have a vertex, a turning point, and absolute value graphs have an axis of symmetry. Okay? Here is an example on the upper right-hand side, a teacher-generated example of a transformed absolute value graph. Okay? So y equals a slope, it's a vertical stretch or compression, x minus h, h is always with x, it is a horizontal shift to the, in this case, to the right 3, and k is a vertical shift. And you can see that this graph goes up 1. Okay? So now I want to demonstrate how these three graphs, these three numbers, change a graph, okay, in the plane. And I'm going to do that with Desmos. Okay. Here we are looking at Desmos, and this is what we call in mathematics the parent function of a graph. It is the simplest form. Usually they're centered at the origin, and you can clearly see that this is y equals negative x, and this part is y equals x. Okay? So let's see what A does first, okay? When the absolute value of A is greater than 1, look at what happens to the graph. It gets stretched. Instead of the standard y equals, see? When x is 1, y is 1. When x is 2, y is 2. See that? But when it's stretched, look what happens to 1. There is when x is 3, or y is, there you go. when we've stretched it 3. Okay? So when x is 1, y is 3. You see that? Okay. When a is in between 0 and 1, so in other words, when a is a fraction, it's a compression. See how that's a much flatter graph than the other ones? So there we go. So there's A. Okay. Oh, and when A is negative, it's a flip. The graph is reflected, is the proper way to say it. So let's see what H and K do. When H is a positive number, which means we're just plugging a positive number into this equation, and so it looks like it's a subtraction. Okay, we're shifting the graph to the right. Look what happens when we put in a negative number, which would change this sign to a plus. So it's backwards, but it works. So you can shift, H shifts a graph right or left. Okay? And K moves a graph up and down. I hope that this is enough information for you to be able to go ahead and complete the activity. Hang in there. We'll be doing more of this later. I'll see you in the next video.